Okay, some people asked me to review our notes that we learned over writing formulas. So that's what this quick video is going to be about. All right, we started off by learning to write ionic compounds. Remember, that's going to be a cation and an anion. The metal will always be the first word in the name given. So here, Ba will also be, it'll also be the first element. So here, Ba, barium, is our metal or our cation. And remember, cations are positive, so that's the cation. And our anion is nitrogen. Okay, so we learned how to write the formulas. If the first part is a metal, we're going to write the symbol. We're going to find the charge, and we can see if we can cancel or reduce the charges. Remember, we learned the Hill method, group 1A, 2A, 3A, 4A, 5A, 6A, and 7A on the inside. Group 1 is a +1 charge. Group 2 is a +2 charge because it gives up 2 electrons. Group 3A is gives up 3 electrons, so it's +3. Group 4A, the carbon group, gives the nonmetals receive 4 electrons, and the metals will lose 4 electrons. The nitrogen group will gain 3 electrons. The oxygen group will gain 2 electrons, and the halogens group 7A will gain 1 electron. The number which indicates how many atoms of each element are present in a compound is called the subscript. So there are 3 atoms of barium and 2 atoms of nitrogen. We never write a subscript of 1. Okay, so let's look at what we learned for a metal and a non-metal. And before we get started, actually let's look at our periodic table that we used. And here we labeled +1, +2. Remember, the transition metals are +1 to +4, so can be up to +6 in some cases. The boron group +3, plus or minus 4, -3, -2, -1, and then the noble gases do not react. Okay, so looking at this, we learned calcium phosphide. So we wrote calcium, Ca, we looked up the charge, +2, and we wrote Ca +2. Phosphide, which is phosphorus, is a -3. We swapped and dropped or crisscrossed them and got CaP2. Okay, so then we're going to look at magnesium oxide, Mg +2 because it's in group 2A. Oxygen is -2 because it's in group 6A. These guys cancel and we have MgO. Because remember, an ionic compound is the least common ratio, or the least ratio from cations to anions. Alright, so let's notice here the last part, or the second name, ends. Notice that the second part of the name is a non-metal. It ends in IDE. So these are the ones you needed to memorize, and you'll get used to writing this, and I'm sure you already have, hopefully. Hydrogen is hydride, phosphorus is phosphide, bromine is bromide, chlorine, chloride, nitrogen, nitride, oxygen, oxide, and so forth. So then we practice some problems. Li +1, sulfur -2, swap and drop, and we get Li2S. Then looking at one with a polyatomic ion. This is our only positive polyatomic ion, NH4 +1, bromine -1. So these are NH4Br. Strontium selenide, Sr +2. Selenium is -2 because it's in group 6A. SRSE is the answer. Now, let's look at if we have a metal and a polyatomic ion. So, for instance, sodium chlorate. Remember, guys, you must memorize those polyatomic ions. So, sodium is a +1, ClO3 -1, swap and drop, and we have NaClO3. Then we learned strontium sulfate, Sr +2, SO4 -2, and those guys cancel out for a 1-to-1 ratio of SrSO4. We did some more examples here. Now, the metal ion has a charge other than 1. We're going to put parentheses around the polyatomic ion and put the number on the outside. So, Ba plus 2, hydroxide minus 1, and we have BaOH2. Remembering that hydroxide and cyanide are our 2 exceptions to our polyatomic 8-ite rule. Okay, so then we practiced aluminum dichromate, germanium phosphate, and sodium acetate. Okay, now we learned how to write using Roman numerals for our transition metals. So the Roman numeral tells you the charge of the metal ion, meaning that you don't have to look up the charge. Almost all transition metals will have a Roman numeral in the name because the charge varies. We learned the Roman numerals. So then we had copper 2 chloride, Cu plus 2, Cl minus 1, swap and drop, and we have CuCl2. Now iron plus 3, oxalate minus 2, swap and drop, and you have Fe2. Now don't forget to put this guy in parentheses because there's more than one. Otherwise I'd have 43 oxygens bonded to carbon, not thinking that's possible. Now titanium 4 bicarbonate. So Ti plus 4, HCO3 minus, swap and drop, and you have TiHCO3 4. Continuing on the ones we practiced. You all have these notes. Okay, then we practiced some more. Then we learned some exceptions to the rules. We learned the exception of zinc always being plus 2, cadmium always being plus 2, as well as mercury and silver. If we look, zinc, cadmium, and mercury are in the 3D10, I'm sorry, not 3, but the D10 block, and so they're readily going to give up that lower level S block before they give up that big, happy D block. Extra ions. Electrons, not ions. These transition metal, yes, these are transition metals, but they have only one charge. Because of this, they will never have a Roman numeral in the name. Remember, Roman numerals are only necessary with all other transition metals because their charges can vary. Now, exceptions with lead and tin. Even though that they're in group 4A, they're always going, they will have to have a Roman numeral even though they're not transition metals. So here, lead 4 oxide, lead plus 4, oxygen minus 2. Don't forget those guys will reduce. And then here's an example with tin 2 fluoride, Sn plus 2, fluorine minus 1, swap and drop, and you have SnF2. Now to name these guys is the reverse of the swap and drop. I can go into that later if you need me to. So we then learned writing acids. Hydrogen is the first element. Always for acid is the second name. If the first name starts with hydro, then the acid is then the acid contains hydrogen followed by an element. Hydro indicates that an element follows. We're going to write H plus 1 and the element symbol, charge, and swap and drop, just like ionic. The ending on the first word when hydro is present is always IC. Okay, and also if we notice, only hydrogen will ever change subscript. The actual element or polyatomic it's bonded to will never, because hydrogen's a plus 1. Now, if the first name does not have the hydro prefix, then the acid contains hydrogen followed by a polyatomic ion. If the ending of the first name is ic, then the polyatomic ion ended in ate. If the ending of the first name is OUS, then the PAI ended in ITE. So you're going to have to come up with your own little mnemonic. I got sick when I ate, or I got nauseous when I ate last night. Whatever you want to do to remember ick, ate, us, ite. Alright, so here I'll practice these guys since we did these on the board. Hydrochloric acid, hydro, remember we write underline that prefix, so we have H plus 1, Cl minus 1, swap and drop, and we have HCl. Chloric is 8 because we have no hydro. H plus 1, ClO3 minus 1, swap and drop, and we have HClO3. Chlorus is ITE, so this will be HClO2 because ite is one less oxygen than 8. Chromic will be chromate, So here we'll have H plus 1, CrO4 minus 2, swap and drop, and we have H2, CrO4, and so forth. Let's see. Now we're going to go to the easy stuff, writing in covalent bonds or molecular bonds. Using prefix. This one is the easy one. The prefix is the subscript. There are no charges. I know I'm going fast, but I'm just trying to keep this video short. So dihydrogen dioxide, same as hydrogen peroxide, H2O2. Triphosphorus pentoxide, P3O5. Carbon monoxide, CO. Here, this of your notes tells you everything you need to know about writing formulas, getting you there, okay? If you have any questions, please ask.